Okay, kids, welcome to 5.7, Solving Trigonometric Equations. This is the last section we're going to cover in Chapter 5, and basically it's just applying what we've done to a little bit more general algebra. And we solved a lot of equations that have already had some trigonometry in them. A lot of the times when we were trying to find an angle with law of cosines, we'd get down to the bottom of that equation and it would say, you'd get to a point where it said cosine of c equals 0.72, and you use that to try to find the angle for cosine. These are going to be a little more general in that you're going to get some equation that might start off looking something like this, but instead of an x, it might have a cosine, or something like this, but instead of x, it might have a tangent or a cosine or some other trig value. Which is why I'm reminding you of how to solve these kind of equations at the beginning of these notes. What you're going to do at first in that situation is solve this as you would normally if it was just x and x squared, which you haven't done in a long time, I realize. So we'll have some practice doing that. And that will end with, this would end with something like x equals some number, or x here it probably might be two different numbers because it's a quadratic. But it won't just be x now, of course. It'll be something like cosine of c equals the other two numbers. And then we're going to have to interpret then what to do with that final inverse cosine step, which in and of itself would be one thing, but they're also going to throw in there sometimes, well, at the end of that, you might find out that you've got this sine value that turns out to be that solution, but they stipulate that this angle theta might have to be in a certain quadrant, because remember sine. For every sine value, if this sine value is negative 0.36, there's actually two angles in the unit circle that have that same sine value. They look like this. This is gone over in the notes, but that's what they look like. Or if you had some cosine value, and you had to find the inverse cosine. Well, every cosine has two angles that could go with it. So we're going to talk about how to find the one that might not necessarily be the easy, friendly one that comes out of the calculator, or how to generalize. How do we get all of the solutions that are always going to have the same sign? So let me point at this one for a bit here. The solution to that one before, if the sine was negative 0.36, negative 0.36 is right here on the y-axis. So that means we're looking for an angle in quadrant 3. That's what was specified in the problem. We were looking for an angle in quadrant 3 that had that as its height, basically, or that as its sine. Well, if you put that in the calculator, you get this one. This one has that height, has that negative 0.36 as its sine value. And it turns out in the calculator would give you a negative 21.1 degrees, which is perfectly true. However, we didn't want that one. We wanted the one over here that the calculator won't show you, that has the same height, has the same sine value. How do you find this? Well, this is the reflection over the y-axis of this same direction. This direction reflected over the y-axis goes this way. We usually thought about that in the first place, talking about two angles that might be reflected across the y-axis up here. We had one angle over here and its supplement. And that's how you reflect over the y-axis. You find the supplement. Supplementary angles add up to 180. So to figure this out, all I have to do is take the original angle and subtract it from 180. Now it looks a little funny down here because we're talking about a funny little negative angle. But you do the same thing. 180 minus negative 21. You can keep that negative. 180 minus negative 21, and I left off the point 1 there, sorry. Negative 21.1 should be positive, so it's like adding, positive 201.1. Oh, it's 3 o'clock. Okay, I'm not done yet. So, yeah, these are still supplementary. These two angles add up to 180. 201, if I had the point 1 on there, and add this on, 201.1, they add to 180, so they're still supplementary. So in sine, that's how you find other equivalent angles that aren't necessarily in the zone that the calculator is going to give you, that also have the same sign. And as we go on, we'll talk about what happens if you had a cosine and you had to find the equivalent in another quadrant, or what if you had the tangent and you had to find the equivalent in another quadrant. Okay, so say we're in the middle of solving some problem, and we got all the way down here to the point where we found out that the cosine of our angle was supposed to equal 0.456. Fine. And we're going to do this one in radians, just to mix it up a bit. And they tell you that they want that angle. You know from the beginning or the context of the problem that we're looking for an angle A in quadrant 4. And, you solve whatever nasty thing you started with, and you get to this point where the cosine is 0.456, and the angle is supposed to be between 2 pi over 2 and 2 pi. In other words, quadrant 4. In the good old innocent days of things like law of cosines, you would just take the inverse cosine of 0.456 and you'd get an angle. I can do that on my calculator. I've already done this one actually. Make sure you're in radians for this. I said this problem was in radians. And if I found the inverse cosine of 0.456, that's going to give me an angle 1.09. Oh, I messed up on the... Oh, that's why I restarted. See, I made this mistake, and then I thought, you know what, I'm going to go back and change it. And I went back and I started over, and I've done so well this time. But you know what? I didn't erase my mistake number. So, anyway, okay, here's a bonus question. Figure out what my mistake was. How did I get the wrong cosine? Anyway, the correct cosine is 1.097. So let's go back and change this. This isn't supposed to be this. See, here's the wrong one. I'm going to erase that so fast you can't tell what it was. All right, it's supposed to be 1.097. By the way, this is the first time I ever had to restart one of these by making such a bad mistake. Anyway, enough about that. So the cosine of 0.456, sorry, the inverse cosine, see, now I'm all flustered. The negative cosine, the inverse cosine of 0.456 is 1.097 radians. So in the unit circle, see, now I think I'm fine now. I think all the mistakes are behind me. Cosine inverse of 0.456. So there's this x value. Remember, this is supposed to be a cosine. So there's an x value of 0.456. Remember, this is at 1. When you ask the calculator what angle, what value of radians has this as its cosine, as its x value, well, the calculator is going to give you this one up here. And this is the 1.097 radians, is the one that kind of goes that direction. But I don't want that one. That's in quadrant 1. I want quadrant 4. There is an equivalent one down here that will have the same x value for that spot on the circle. So see, these have the same x value. This one is approximately 1.097 radians. But that's no good. I don't want that one. It's in the wrong quadrant. That's not between 3 pi over 2 and 2 pi. It's between 0 and pi over 2. That's not good. Okay, so I want the same value down here. Well, back in last chapter, we talked about all these equivalencies and how to, the identities of trigonometry and how come you can get the same, how to find the same value of cosine at different angles. If I'm saying 1.097, I'm talking about rotating this 1.097 radiuses, or like radians, that way around the circle. Well, this is the same amount this way. It's just in this direction. So for cosine, you can just kind of think about how this one was a positive rotation at that point, and if I go that direction, it would be a negative one. So really, yes, this is true, but you can also say, to rewrite this one way is to say, well, then the cosine of 1.097 radians is the 0.456, which you could say is a solution for this. That tells me A could be 1.097. What I'm saying also is, you know what? This also solves it. If that had been negative 1.097, it would also have the same cosine, because it's the same amount of rotation. It's the same angle space away from, the reference direction here. It's just the other direction. So you can just flip a cosine to a negative inside here, and it's the same thing. So in this context, if it's supposed to be quadrant 4, I would want this angle down here. Now, you notice this number, negative 1.097, is not between 3 pi over 2 and 2 pi because it's negative. So this is the correct location, but I don't really want to call it a negative angle. I was supposed to call it a positive something between 3 pi over 2 and 2 pi. So to do that, if it's negative 1.097, I could just take this thing and essentially rotate it another 360 degrees, or rotate it 2 pi radians. I'll just add 2 pi radians to it, and it will be in the same location on the circle. So let me do that. Here we are back on the calculator. Number's still in there, plus 2 pi. You can always add or subtract any numbers of 2 pi. We're going to come back to that later. What? How come I have an exponent? I don't want an exponent. How do I get out of that? Okay. Can I just put a pi here? Oh, I keep hitting that button. Oh, come on. How about we just give up? All right, answer plus... Why is that not answer? I'm having a bad day. Answer plus 2... Oh, I know, it just wasn't taking my second. That's why. It's the right button. Just wrong function. Okay. Answer plus 2 pi is about 7.38. Okay, so 7.38 radians is this much circle. Now, wait a second. That looks way too big. Pause. Oh, I know what I did. I didn't have negative in the calculator. Let's try that again. I'm going to get that exact answer back. You know what? I'm in this mood, then I'm going to get this right if it kills me. All right, let's go back here. I want the inverse cosine of 1/6. Yep, right, good. That's that. But I'm going to call this negative. So negative answer. Come on, calculator. Second. Plus 2 pi. Okay. Or could have subtracted from 2. It's 5.18. That makes more sense. Okay. See, you have to be able to you have to be able to estimate these things. Otherwise, you know, you just get to trust your expensive little calculator here that's electronic and seems like it's giving you the truth all the time. You gotta use your brain a bit. All right, 5.19 essentially. So this is actually 5.19, and there you go. So 5.19 radians is the same as, it's got the same cosine as 1.097. The next step on that equation is if they didn't even just say, okay, it has to be in quadrant 4, they might say, give a general solution to all possible numbers that could ever solve this, which is kind of crazy to ask, it seems like, because there's an infinite number of answers to that. Because as you go around and around the circle, say we start at 0. I know it works at 1.097, it works at 5.19. It would work if I kept going and I kept going past 2 pi. Eventually I would land here again, and it would be another solution. It would be, I don't know, maybe 7 or something, and I keep going, and it might happen at 11 point something something something, and I keep going, it would happen again and again and again. Or if I started at 0 and backwards, it would happen at negative 1.097. We just said that. Keep going backwards, this is probably negative 5.19. Keep going backwards is negative whatever, and keep going negative. So there's an infinite list of things it could possibly be. It could really be 1.097 plus, say this location and all its equivalents as I keep going around and around and around the circle, plus 2 pi, and I could add on as many 2 pi's as I wanted to. I could add on 1.097 plus 2 pi would be right there. If I added on 4 pi, it would go right there. If I added on 6 pi, it would go right there. So what they do to generate this list is say, okay, that's all of these are, any angle that's going to end up here is going to be 1.097 plus some number of rotations after that. So full rotations are counted in 2 pi's. 2 pi times n, where n is any integer. So for any integer n, this will tell us this is like 1.097 plus 2 pi, if n is 1, plus 4 pi, plus 6 pi, plus 8 pi, and it'll keep going there. And the other solutions are 5.19 plus any number of rotations. Now, of course, if you're in degrees, we'd call this 360 instead of 2 pi, but yeah. And notice, since n's an integer, it could be positive or negative. So this is also going backwards. This is like if I went backwards, negative 2 pi or negative 4 pi or negative 6 pi. So here's all the solutions that could ever possibly be A. Here's the one that's in quadrant 4. That's a quadrant 4. This is all. And depending on the problem, you might get one where they stipulate a quadrant like that. Or they might say, give all the solutions that it would ever work for this. And there's the list. Okay, I do a sine example in the handout notes, and I just did a cosine example where you have to try to find the equivalent angles that have the same cosine, or the equivalent angles have the same sine. So I'm going to do a tangent one now, and this is one of those bigger nasty equations that has like a great big other mess of stuff to do. Okay, so first of all, let's just pretend, instead of all these tangents being in here, because that's just hard to write, let's just make a little substitution here. For the time being, let's just let tangent of x, because I don't want to write tangent x over and over and over again. Pick your favorite letter. Let's say, C for Craig, fine. So let's say now, this is not 3 times tangent squared, let's call it 3c squared plus 4c plus 1 equals 0. And see if we can find that. Oh, by the way, this equation we're going to try to find all the solutions for x that work for this. Okay, so I'm going to go solve this in the manner in which I'm used to doing, and I'm going to pause and do that off the clock because I'm about to run out of time in this video. Okay, so the first thing I did was I solved the equation for c, and I got 2 answers. C could either be negative 1/3 or it could be negative 1. Now, in the unit circle, I'm looking at places where the tangent, remember that c stands for tangent, so I'm looking for tangent of x equals either negative 1 or negative 1/3. Tangent of negative 1, that's pretty easy. Tangent of negative 1 is these numbers, where we're at negative 45 degrees or 135. Tangent of 1/3. Oh, I'm going to have to go part 2 on this video. I can tell right now. All right, I'm going to back up and I'll resolve that. See you in part 2.